Hey, so welcome back, and this is another daily code problem. So today's April 3rd, and we got a question called Boats to Save People. So let's take a look at it. And so today's question is a medium level question, and you're given a people array along with a corresponding limit. And what you want to do is you are given an infinite number of boats, and you want to save these people. And so each person has a corresponding weight. Like in this array, there's a person that weighs 3, 2, 2, and 1. And you have a limit of 3 here. And that limit is like the weight limit of each boat. Now you have an infinite number of boats, but naturally you can have a limit of up most to 3. And then also, and I actually didn't catch this the first time I read it, so I got the answer wrong initially, was you can carry at most 2 people at the same time. And so you have this many people, you have 4 people, each boat can carry 2 people at a time, and the weight limit is 3. Okay, and so the first approach that I took when thinking about this problem is I sorted it. And so I got it as 1, 2, 2, and 3, just because I thought that, okay, if you have a weight limit of 3, you can kind of move from left to right here and just add the values as you go. And so you add 1, then you look to your right and say, okay, I'll add 2 here, so then I have 3, and then I look at this one here, and then so this is a boat, and then I grab 2 plus 3 is too big, so I wouldn't add it. So then I have a third boat, and then I add this one, which is 3. And that works pretty well, just kind of moving left to right. But this actually won't work, because there are cases where, let's see if there is one here, 3, 3, 4, 5. Is that one? No. It's basically cases where, okay, if you are moving from left to right, and say you have like 1, 2, 2, 2, and then like 5. And so in this case, say if we're going from left to right and we sorted it, and you can have upmost of 6, then what you want to use for your boats is 5 and 1, and then these 3 here. Oh, I guess you can't do that. Let's say that this is actually 1, 2, 4, and 5. Yeah. And then you can have at most a weight of 6. So you want to grab this one, and then these 2 here. Right? And so, but if you're going from left to right and just reading it and just keep adding until you hit the limit and then do this kind of greedy way from left to right, you won't be able to catch these cases where, okay, I want to grab these 2 together and then these 2. And so what you actually want to do is, once again, if we look at that case, so 1, 2, and let's maybe add 2 again here, 4, 4, 5, is that once again you want to sort the array, but then you want to have a right pointer and then a left pointer. And then you constantly just compare the right and the left and see if you can include either or. You first check if you can add 5. So if 5 is less than the target, which is 6, then you add it. And so the current running sum is 5. And then you move your right pointer over to here. And you say, okay, can I add 4? So 4 plus 5 is 9. So nope, that won't work. But can I add 1 to 5? Yes, I can, because that's less than or equal to 6. And so then there's a boat. And so once again, you move your left pointer, and so you no longer look at these 2 values. And then you say, okay, is 4 less than 6? Yes. And then is 4 plus 4 less than 6? No. But I can add the one on the left. So once again, like, these pointers move forward and backwards. And so you're constantly checking, can I add the value at the right pointer? If so, then I add it. and I keep checking the right pointer until I can't add it anymore, and then you start adding from the left pointer onwards. But naturally, you can only have 2 people per boat, and so that's the other condition. And that's the algorithm. So it's n log n time complexity, because the bottleneck here is the sorting. Because after you sort it, you just have a 2-pointer method that just iterates forwards and they meet in the middle. And so that's just O of n time. And then for space complexity, it's just O of 1 because we're not using any extra space. So let's go ahead and write out this algorithm. So naturally, we want to return the number of boats that we use, and that will be initially set to 0. And then we're also going to want to keep track of the current running total of people, so the number of people. So let's just say like people. You also want to keep track of your left and right pointer, and so that will be first set to 0, and then the length of the array -1. Actually, I'm just going to copy this. I renamed this as A just to simplify it for me, but I want to make sure that we have the same variable names. So it's actually called people. So the length of the people array, and I think that the number of boats, I think that's about it. We might need one more variable, but so we say, okay, while our left pointer is less than or equal to our right pointer, and this is just templating for when you want to meet in the middle with a 2-pointer method. It's also used for binary search. And then you say, okay, if our current running weight, so that's the other, so we'll say like weight. So if our weight is, if the weight plus the value or the weight of the person at our right pointer is less than or equal to our target or our limit, then we'll include it, because naturally if we can include that weight on the right, then we'll do it. So we want to include that person in the boat, but then also you want to say, okay, and that the number of people in our boat is less than 2. So people is less than 2. Great, and so let's add that person to our boat. So we say, okay, people plus 1, and then we add to our weight that person's weight, and you continue on. So then after that, what you want to do is say, okay, oh, and the other thing that we have to do here is naturally if we added that person, we want to decrement our right pointer, and so we say r minus equals 1. Otherwise, if we can include the left-hand person, we will. So person at the left pointer is less than our limit, and the number of people is less than 2. Then pretty much the same logic here, except we want to add to our left pointer and add the person on the left. Great, and so the other case is just otherwise. What we want to do is just say, okay, we can't add any more people to this boat then let's just add who we have on the boat and just move forward. And so we say, okay, then we want to set the number of people to 0. We want to set the weight, and let's increment our boats. So that increments the count of our boats. We reset the people to 0 because now there's no one else in the boat because we just used 1. And then the weight that we're currently at will be then equal to the people on the right. Or no, you don't have to do this, I believe. Yeah, great. And so what we can do, I believe, is then we just say, okay, given this case, eventually these will overlap because they're going to be meet in the middle, and you might actually have a person on your weight count, and this is an edge case where they haven't kind of hit this else case, and so you want to add that person. So if the weight is equal to 0, then we just send the number of votes that we have. Otherwise, let's return the number of votes plus 1. Let's try running that. I wrote this a bit different than when I did it. Oh, TLE. So what we're doing is left and right. So we do that. So I believe this is because we're incrementing the number of people. We add the weight. O plus equals 1. And so I think this is a case where, okay, you keep hitting this else condition. So what we can do is we'll just always say that we add someone each iteration. Someone's always going to be added to the vote. And so someone's added in this vote, someone's added in this case, but in this case, we also want to add someone. So then let's just set our weight equal to the person on the right. And naturally we want to subtract by 1 here. Great. Yeah, so it was just constantly iterating through this loop here and hitting this else case. So that's why we're getting that TLE, like that infinite loop that we're running. And so we can just handle it by, okay, saying, let's just always add someone. And in this edge case, we'll just add the person on the right. Okay, so let's try running that and submitting it. Oh, something's wrong here. So, oh, I forgot to sort it. Let's go ahead and sort it. Let's see our people array. Great, let's try running that. And that's the algorithm. So yeah, so once again, I think it makes sense to think about sorting it since you want to try to handle the weight and you care about, okay, let's try to add as many people that weigh the most and then pair them with people that weigh the less to try and find, okay, if we're given 5, we can have at most 6 people. Let's try to find someone that weighs 1, you know, and so forth. And you just kind of, it's a greedy algorithm where you want to greedily pick people. And I think the intuition behind this just comes naturally. Like you have to think about, okay, can I sort this? Can I look at it forwards, backwards? Should I iterate backwards? Should I have 2 pointers, 3 pointers? Like, and I think a lot of those techniques you just roll through when you read a question. So it's a great problem to practice with. I think it's a great medium level question and I hope you enjoyed it. So have a great day and good luck with the rest of your algorithms. Thanks for watching.